All right, good morning. How's everyone doing? Let me share my screen. Awesome, awesome. All right, let's start with ODPs because there was some confusion and some issues on ODP 450. A lot of people figured this out in the end. But just to make sure everybody is up to speed on string processing, let's run through ODP 450. So you were writing a function called clean, took in an array of characters, which was a char star, removed all occurrences of the letter X from the argument, and then return. Now when you pass a string, if you modify that string in the function, that changes the string in the function that in the program that called the function. We looked at some code for that yesterday, where we just wrote a junk clean function that truncated the string, right? So the function is void; it doesn't return anything, but it modifies the argument. Okay, so your goal was to take in this argument, remove the x's, and then just return, not return a value, but the function will have modified the string. And so let's look at some code for doing that. So and this follows the pseudocode we did yesterday, right? This doesn't have to be 1120. This is just 120. So take in your argument. I'm calling that in. First thing I do is I copy it to an old, so I make a copy of it. And then J is my output location. And I move through the input string, and I include the null terminator because I loop less than or equal to the length of my input string. And if the character is not an X, I copy it into the output string, and I increment my output location. And since I'm including the null terminator, once you've exited this loop, you know you've copied all the characters, including the null terminator, into the output string. So that gets you ODP 450, right? And you can modify what you did for 450 to get 452. So let's take a look at that one, which is due tomorrow morning at 8. So ODP 452, exactly the same thing as 450 with one change, which is that it removes only the first occurrence of the letter X. Okay, so same thing, take your input string, make a copy, move through your copy, copying characters to the output string that you want to appear in the output string. The only difference is just remove the first X. But this is a big difference. All right, so let's code this out. For each character in the original, and let's have some output location, which we initialize to 0. For each character in the original, if character is not an X, copy to the output. Right, and then increment your output location. So here's the original. Right, with a bunch of X's in it. And here's the output. And our output location equals 0. So this is 450, right? If the character is not an X, we'll copy it to the output, we'll increment the output location. And I'll label my character numbers. All right. There's one other condition we need here. So if the character is not an X or already skipped an X. So we're going to use a flag. And we're going to initialize, an int already skipped an X. We'll initialize that to 0. So the first time you encounter an x, right, this part of the if condition will fail, but already skipped an x is a 0, that will also fail. And so we're not going to copy that x to the output. We're not going to move into a new location in that output string. All right, so this is an if statement. And then all we have to do is say if the character is an x, then already skipped an x, set that to 1. All right, so this is a flag, right? This flag is being set once we know that we've skipped an x, and once we know we've skipped an x, we should just copy every single character. All right? So what does this do? Output location is 0. We're going to go through each character in our original. So we're going to start with the h. It's not an x. We'll copy it to output bracket output location. We'll increment output log. Here's an e. It's not an x. We'll copy it to output location 1, and we'll increment output log. All right, here's an x. If the character is not x, well, that fails. Or already skipped, well, that fails also. So we'll copy the character to our output location. That's location 2, and we'll increment this. But now, if the character is x, we're going to change already skipped to 1. So already skipped and x, that was a 0 to begin with. Now we're changing that to a 1. All right, go through the next character. There's an O. It's not equal to an x. We'll copy it to output location 4. And 3. We'll increment this. All right, now we come to the next character, and it's an x. If character is not x, well, that fails. Or already skipped an x. Well, that is equal to 1. That's true. And so we're going to execute the body of this if statement, which says copy our character to output location 4, increment our output location. There's an A, it's not an X, that gets copied to location 5, and we increment this to 6. And last character we encounter is an X, and again, this part of the if fails, but this part succeeds because already skipped is 1, which is true. And so we'll copy that character, the X, to output location 6 and increment this to a 7. And then we're done with our loop. And then I could do, out bracket output location is the null terminator. And output location is a 7, so this would put a null terminator right there. And there's your correctly cleaned up string. Except I messed up when I did this. I actually copied the X. I shouldn't have done that. But anyway, if you were playing along at home, hopefully you saw that works. So that first X would have failed because that was 0, and that was not true either. So I wouldn't have copied the X. All right. So punchline, right? Same code as before, but set a flag the first time that you skip an X. And if that flag is set, don't skip any more X's. All right. This is a different style of programming. This is what I call stateful programming. It's like a state machine. What you do in the body of this for loop is not always the same. Sometimes when you see an X, you skip it. Sometimes when you see an X, you copy it. Okay, and there's a notion of state. So this is all ODP 452. There's a notion of state. So my state variable is this already skipped an X. So state equals 0, skip X. State equals 1, include X's. And how do we make the transition from 0 to 1? Well, after you've seen an X and you've skipped it, change your state to 1. And once you're in state 1, you stay in state 1 forever. State 0, whatever your input is, if it's not an X, you copy it to your output. State 1, whatever your input is, including an X, you copy to your output. And we make state machines all the time in programming. Your operating system is a big state machine. Any game that you play is a big state machine, right? An editor is a state machine. Anytime that you have the notion that what a piece of code does depends on what's happened in the past, you're talking about a notion of state, right? That's all a state machine is. That's why it's different from combinational circuit. When I hit the left mouse button on my mouse, what it does is not always the same thing. If I've just booted up, chances are hitting the left mouse button doesn't do anything. But if I've just opened up a Word document and I hit the left mouse button, there's a good chance it's going to move the cursor, which will subsequently change what happens when I hit a key. So everything is stateful. All right, let's see question. Is it bad to work with a string that was passed to clean directly? I didn't declare any variable, use any function, it's just while loops. So first of all, in ODPs, I have no problem with you writing functions, making extra variables, doing loops, anything that you want. But let's see, is it bad to work with a string that was just passed to clean directly? No, and I saw some elegant solutions that basically, instead of making a copy and working with that, modified the string itself. It's a little trickier to do, but you can do it. And it's a reasonable exercise to challenge yourself with if you want to, flex your string processing muscles. It's a good thing to work on. But I think a more direct approach is just using a separate output string and copying. But yeah, either way is fine. Whatever works for you and makes sense for you, that's what I want you to be doing. Except for calling, sed or something. All right. So 452, do the same thing for 450, but just throw in that notion of a flag or a state variable, right? And just copy everything once you've skipped one letter X. Okay. All right. Other questions on anything? Any final homework 6 questions? Homework 6 is due at 8 tomorrow morning. And hopefully anybody with questions came by office hours last night. Had a few takers, which was productive. Yes, and the person who sent me an email, I sent you a reply with some details on those error messages. Let me just point out the grading rubric for this assignment, right? Even if you cannot get a program that plays high-low perfectly, right? Do as much of this assignment as you can and get it turned in before 8 o'clock tomorrow morning, okay? If your executable is named main, you get 5 points, right? That means your program has to compile, right? But if it compiles and it's called main, you get 5 points, okay? If you can process the command line arguments successfully, that's something from past ODPs, past assignments, it was on the midterm. Hopefully everybody can figure out how to process the command line arguments. Look what you get. You get 5 points for detecting there's no arguments, 5 points for parsing one argument and saying, the range is from 0 to that, 7 points for parsing 2 arguments and saying the range is from first number to second number. And if you do the scanf with a %s to make sure these things are valid, you get another 7 points. Okay? That's all stuff from weeks ago. Okay, if you print a message in the beginning which says, you know, welcome to my game, let's play guess a number between 50 and 150, right? That's another 2 points. And if you throw in an fget statement that waits for the person to hit the enter key, that's 3 points. Okay, so that's 10, 17, 19, 29, 34 points right there, basically for being able to process command line arguments. All right. If you write your predict function, which you know I gave the algorithm for, and I think most people started working on the predict function earlier, which is cool. That's worth another 10 points. All right. And then, you know, even if your program doesn't, you know, have the right algorithm for guessing and doesn't do the looping correctly and things like that, if you split it into the required functions, if you have a make file that works, and if your Git repo is clean, right, that's another 27 points. So you're already up to like 50 or 60 points, even if it's not playing high-low. Okay. And then, you know, the actual, you know, make a guess that's in the middle and take an answer and adjust your guess accordingly and detect cheating, those are the remaining points. But as much as you can get done, go ahead and get that cleaned up and submitted and make sure it's there by 8 in the morning, right? And then we can modulate on that. All right, can we go to office hours and have you test our code? So there's no more office hours until Friday night, but in general, if you want, you can come by office hours and show me your code and demonstrate it for me. And I might suggest some other test cases to try, and we can do that, you know, while you're screen sharing. And then if there's, you know, questions about why did this happen, yeah, I'm happy to go into your code with you and help you try to figure those things out. That's exactly the kind of thing that that office hours would be for. All right, is it okay if we specify the number range within the press enter statement instead of in the greeting? Sure, that's fine. Yeah, all of that's considered greeting. So I just want to, I want some kind of greeting, right? Don't just start off waiting for the user to get to type a number, or, you know, to type high-low. I want some kind of greeting. I want to see that you've processed the high-low range correctly, and I want it to give the person a chance to think of a number before it starts guessing. So, but if you print out that high-low range in the greeting, or, you know, when you say think of a number or something, that's fine. Let's see. So get answer function. Yeah, get answer can be tricky because we're dealing with strings in there. But let's see. Let's say you have an answer. They should only be saying H, L, or C, right? So this doesn't have to be terribly long, but I always make my strings 120. So do your fgets, get your answer back, right? Remember, fgets is going to throw a null terminator, a new line on the end, along with a null terminator. So there's 3 valid possibilities for answer. It could be an H followed by a new line. It could be an L followed by a new line. It could be a C followed by a new line. All right. So you can check these explicitly. You can check character 0 to make sure it's an H, C, or an L, and check character 1 to make sure it's a new line. So some if statements. You can do our truncation trick where we change our answers by getting rid of that new line, in which case your answer would be either H, L, or C. And then I've seen some people check the string length to make sure it's 1, and then check character bracket 0 to make sure it's an H, an L, or a C. You can also use string compare. And you can put in a string over here, and it will tell you if your answer matches that exactly character for character. And you can actually do something like h\n. And string compare will return a 0 if this string matches that. And it returns non-zero if it's different. Right? Although I kind of like this approach or this approach. But string compare is another option. And there's other things I've seen people do that work also. And then you got to pass things forward and backwards and stuff like that. So yeah, that takes some gymnastics. All right, cool. Other questions? All right, let's talk about GDB. So this could be one of the more important lectures of the course, possibly of the whole CS sequence. GDB is a really powerful tool to have in your toolbox. It's the way to debug programs or functions that aren't working the way you think they're supposed to be. And I want to play around with this with some ODP 450 code that I wrote up, some of which works, some of which has errors in it. And I want to look at how we can play around with GDB. GDB is always available in Unix. It's representative of debuggers in general. We've looked at it a little bit. I'll give you one anecdote. I've got tons of videos that I've made. I've got lots of videos on computer science and logic and original research, and I've got a whole channel of artsy videos I made where I pour my soul out, and most of these videos, they get, a few hundred hits maybe. A few of them have gotten a few thousand hits, over time. Several years ago, I had some former students at WSU, and they said, hey, Nick, we're struggling with GDB. We don't know how to use it, and we're expected to know. Can you give us, a quick overview? And I threw together like a 15-20-minute video on GDB, and that's got, close to 200,000 hits on YouTube. GDB is huge, okay? Knowing how to use it can save you a lot of time in debugging. It doesn't really do anything that you can't do with just a lot of print statements, but throwing in a lot of print statements in your code is not a lot of fun. And GDB lets you be very sort of tactical in where you focus your energy when you're trying to debug. So first thing is, if you want to use the GNU debugger, GDB, ideally you're using this on code that you have the source code for. Okay. Now you can use this on raw executables, and this is how you do things like reverse engineer code or drivers or games or things like that. It's how you do a lot of hacking. Okay. But if you have the source code, the source files, the .c files for a program, you can make those work with GDB really nicely. And the whole trick is when you compile, after you say GCC, say -G. Okay, that will include debugging information, which will help GDB show you what's going on. So we're going to compile our code with a -G switch. And then when you want to run a program, instead of saying program name, you say GDB and the name of the executable. And GDB will run your program for you, but in a very controlled way. And it's controlled in the sense that it lets you interact with the environment while the program is executing. And so we can do things like single step, say execute the next line of my C program, and then stop. Don't just keep executing, just execute one line. And we can go to the next line in our program, or we can say if that current line in my program is a function call. Let's go ahead and step into that function. Okay, so these are typically called step over and step into. We can print the values of variables. We can examine the contents of memory. We can, to some degree, change the values of variables by saying set. We can make a breakpoint, which says I don't want to single step my program 5 million times, but when you get to this line of code, I want you to stop. So we can set a breakpoint and say stop when you get to that location. We can set a watch point where we say this variable should always be 0, but sometimes it ends up being, 119. I don't know why. We can put a watch on that variable and say as soon as that variable changes, stop what you're doing, come back, let me know. And that can be really useful. Some versions will let you step backwards. They'll let you go backwards in time and undo the execution of statements that have already executed. So if you're running your code and you say, oh, something's wrong, my variables are all messed up, you can actually step backwards to the point where your variables were not messed up, and now if you step forward once, you can see what happened to mess them up. Okay, this is a really, really rich environment for figuring out what's going on in your code. And this is the automated assistive version of what I call playing computer. So when somebody shows me a set of code and it's not behaving correctly, what do? Well, you make yourself a list of variables. This is 1, this is 0, this is what this is, and so on. And you step through your code and you copy from the input to the output, and you update the variables and so on and so forth. You do what the code says, right? The problem with that is what you saw when we did this example was I had in my mind an idea of what this algorithm was going to be doing, and I wasn't dutifully following each statement in my code, which was why I inadvertently copied the X, because I kind of went on autopilot, right? And this is really easy to happen, especially if you've got, thousands of lines of code. It's really, really hard to keep that straight. And if you think that this is going to do one thing and it does something else, you're never going to find that mistake by tracing through this on paper. The debugger will keep you honest. Okay, it will show you what actually happened when a line of code gets executed. And then you can look at the variables and you can say, no way, I said that should be equal to outload plus 1. It was 5. It should now be equal to 6. Why is it equal to 5? Okay, but it's the speaker of truth, right? It will show you what happens inside the computer. And that can really help you sort of narrow down if there's something core that you're not understanding quite correctly. That will help expose it. This takes patience. It takes, a calm environment, and a willingness to sort of, follow through faithfully. So my longest debugging session ever with GDB was about 2 weeks, and it was about 3 or 4 hours a day for 2 weeks, and I was stepping through code one instruction at a time. And every day I would go back and I'd do another, 3 or 4 hours of doing this and confirming that each instruction worked. And after about 2 weeks, I found my bug. It was the hardest bug I ever found. And when you find a bug like that, it usually changes your brain, right? It usually, the worse the bug is to find, the more profound the aha moment when you find it. And, sometimes you can feel your brain shifting shape because so many circuits are getting rewired. Because something really fundamental just clicked, right? And so this is why I say embrace your bugs, right? Don't just try to get rid of them by changing your code. Don't delete your code and start over again. When you have a bug that's really hard to find, you want to pursue it. You want to understand exactly why that's going on. Yeah, exactly. Missing semicolons are like classic. All right, so let's play with some sample code. So I've got some versions of ODP 450, to mess with. So I've got a main program, which was, you know, just my driver code for 450. I already talked to a few people about this yesterday who contacted me, but general comment, right? You got to be testing your code before you assess it, right? If you assess and it says 0 out of 10, all you know is something's wrong, okay? So make yourself a main program. So here's a main program where I called fgets, terminated, you know, took off the new line at the end, printed it out, called clean, printed it out after clean, okay? This was just my test code for testing my clean function. And you got to do lots of test cases, right? And think of edge cases, something with all x's, something with no x's, something with no characters at all, something with an x in the beginning, at the end, in the middle, combinations of those. And you've got to do them in different orders, because sometimes your function works great the first time, but the second time you call it, there may be remnants of the first call. If you're not terminating your string correctly, that can pop up. So you got to do lots of testing. So make yourself some kind of test bed. Here's mine. Okay, this was just something I could use to work with clean. And here's my clean function with some better variable names than I showed you before. So I'm calling my input string new. I've got a temporary variable old, temporary character. I copy my new string to my old. Here's my output location. I loop through the characters in my old string, and I copy that character to C, right? And then if that character is not an X, I copy it to my output string and I increment my output location. And when I'm done, I set my output location to a null terminator. All right, so this is deliberately, you know, put into a lot of code. I could just use old bracket I instead of C, but I want a lot of code here to demonstrate this. Okay, so we can compile this as normally. Right, so that works fine. That works fine. That works fine. All right, so this seems to work, but let's take a look at this in GDB anyway to see what we can do with GDB, and then let's look at some versions of this that have some bugs. So let's recompile, but let's put a -G switch in the beginning. And actually, let me suppose I forgot to put in the -G switch. If I try to GDB main, I'll get this message saying no debugging symbols found. Okay, and if I try to do things like list or right, I'll get the things that we're going to try to do will not work. So go back and check how you compiled, and if you didn't do the -G switch, put that in. All right, GDB main, if it works correctly, it'll say reading symbols from whatever your file name was, and it'll say done. So I can say list, and I can look at my source code. Okay, there's my source code. I can say list again, and it will show me more lines of my source code. And if I say list again, you know, there's only 14 lines in my file. I can say list clean, and I can look at the contents of my clean file. You can also hit enter, and it repeats your last command. So that just keeps listing, and there's contents of clean. All right. So let's say I want to debug my clean function. I'm going to put a breakpoint there. I'm going to say break clean. And now I'm just going to say run to start the action. So it's running the program, and when I run my program, normally what does it do? It waits for me to type something in. So I can say hex x on. All right. And here it tells me it's hit a breakpoint. It's in my function clean. It tells me it was called with one argument, which was this string, right? GDB understands C. It understands, my source code because I use the -G switch. So it knows, for example, that the argument is a char star, and so it will interpret that as a string, and it will show it to me as a string inside quotation marks. And I'm at line 3 of clean.c. And if I say list, right, I can look at the lines around where I am. So I'm right here. I'm about to start executing my clean function. All right. So let's just say next. That says go into the next line. And we see it jumps all the way to line 7, which says string copy new into old. All right. So the line that it shows you is always the line that is about to be executed. Okay. When it stops at a line, it means it has not executed that line yet. So it's about to do the string copy. And I can say print. I'm just going to use P for print. I can say print new. That's what new looks like. Hexaxon. If I print old, it's a bunch of weird stuff. \30 space backquote 000, etc., etc. And I can do things like, print old bracket 0. That's a \30. Old bracket 1 is a space. That's ASCII code 32. Old bracket 2 is ASCII code 96. That's a backquote. Old bracket 3 is a null terminator. And I can say something like print the string length of old. And string length is a funny function. It doesn't actually return an int. It returns something else. So it says I have to cast it as an int. So I'm just going to put, int in parentheses here. And I can see my old function has a string length of 3. My old string. If I print string length of new, it's 7. Hexaxon. And while we're in here, we can play with all of these things we've been talking about the past few days. Right? That's the first letter of my string new. String length is 7, so I've been telling you that if you look at character string length -1, that should be the last character. So let's look at new bracket 6. That's the letter N. That's this character right here. If I were to look at the character after that, that's the good old null terminator. If I were to set new bracket 6 to a Q and then print new, that last character, which was an N, is now a Q. So while you're in the debugging environment, you can actually start doing things that look like C statements, right? I mean, set's not part of C, but we can do assignments, we can do function calls, and this can help you, think about your ideas. If you're at a point in your code where you wanted to, get rid of the new line at the end, you can start, evaluating expressions in C, and that can help you kind of debug the algorithm. All right, so where were we? We were about to do this string copy from new into old. Remember, old is just, random stuff right now. So here, right, I have a choice of saying new or saying step. If I say step, that means step into. I don't want to debug the string copy function. If I say step, that's going to start running me through code that's not stuff that I wrote. So here I definitely want to say next. And in general, you always want to say next unless you're trying to go inside a function that's being called. So I'm just going to say next. Okay, we've done the string copy. Let's take a look at old. Guess what? Old is a copy of new. Hexaxoq followed by an null terminator. And all this other stuff is the same stuff that was in old before. String copy didn't change it. Right? String copy copies everything up to and including the null terminator. All right, now I'm setting my out location to 0. Well, right now my out location is 2656. Why is that? Because I haven't initialized it yet. I'm about to initialize it in line 8, but I haven't executed line 8 yet. And uninitialized integers don't have a preset value. Sometimes they're 0, sometimes they're not. So if I wasn't doing this initialization, right, this would jump out at me when I started trying to go through my loop. The first time I looked at my output location, I'd see it has some bizarre value. All right, so let's go ahead and execute that assignment statement. Now if I look at output location, it's a good solid 0. All right, and so this is the kind of thing that we're going to do in the debugger. You can hit enter to repeat your last statement, which was next, that was n. So now I'm going to go into my for loop. And I'm going to set c equal to the character at position I, and I'm going to see if that's equal to an x. Well, let's print out I, that's a 0. Let's print out old again, that's hex something. So c should be equal to the letter h, which it is. And if c is not equal to x, I should go into my body of my if statement, which I am, which should copy c to new bracket outlook, right? So here's what new looks like before. Go ahead and execute that. There's what new looks like now. And then I'm supposed to increment outlook, and sure enough, that's been incremented to a 1. All right, so you continue like this, and I'm using Control D to quit, but if you have something running, it will remind you you've still got something running. Do you want to quit anyway? I'm just going to say yes. All right, so let's look at a different version of clean 1. Okay, so clean 1 is just like clean, but instead of doing a separate outlook equals outlook plus 1, I'm doing a plus plus. Okay, so an auto increment. So let's compile this up. So gcc-g-o main.c clean1.c. Got to spell it right. And let's run this. So I put in hello, and it doesn't quite come out right. And I put in 3 x's. Well, that comes out straight. And I do HAX, and that's not exactly what I wanted. So let's debug this. So I'm going to put my breakpoint at clean, and I'm going to say start. And I'm going to say continue. Did I do a break at clean? Yeah. Okay, so I have to type in something, so I'll say, you know, HELLO. All right, so I'm inside clean. My test bed seems to be working because I'm calling my clean function with hello. That's correct. Okay. If your test bed has a bug in it, then, you know, you're chasing the wrong bug. So make sure your test bed is passing the right thing to your function. So let's step through our code here. All right. So let's go with next. We're going to copy new to old. We're going to set our output location to 0. We're going to go into a for loop. All right, so let's just double check. New is hello. Old is hello. Output location is 0. We should be all set to go into our for loop. All right. So if old bracket I is not x, so let's look at old bracket I. That's the letter H, not an X. We should go into our for loop. We're going to copy old bracket I to new bracket plus plus outlook. Let's copy that. Let's print new. And something is wrong here. All right? New should have started with an H followed by an E, but that second letter got changed somehow. Let's take a look at outlook. Outlook's equal to 1, which is what it should be after I copy. Right? So what happened here? Well, let's see that again. Let's look at old bracket I. That's the letter E. Let's look at outlook. That's the value 1. Let's look at new. It's an HHLLO. This should copy the letter E. That's this. Into position 1 in new. That should replace that second H with an E. Let's step it. and look at new, that's not what happened. All right. Major head pain now because C isn't working. C is broken, right? So this is a point where you take a walk or listen to some music or something and come back and look at this with fresh eyes. And something is going wrong. Now, if you're debugging this on paper, you're never going to find this because it's exposing a misunderstanding about something in C, right? And the problem here is this statement, right? This is what's called a pre-increment. The way ++ Outlook works, it says increment this variable first and then use it. So even though out location was a 1, before it got used to index new, it got incremented. And so it stored my character in new bracket 2. Okay. Now the debugger won't tell you that. It won't tell you, hey, you're forgetting that ++ happens before you use the variable and the ++ should go after. But it's very definitely telling you, there's something weird going on right here. And that sends you back to your notes and writing some test code and so on and so forth. Okay. So that's kind of a classic example. Let's try a different one. All right, so here's another version of clean. And let's go ahead and run that. Well, let's just try this first. So there's hello, and my cleaned up string has no characters in it. All right. So we go into GDB and we start executing our clean function. It's going to copy new to old. It's going to set output location to 0. We're going to go into our for loop. All right. New is hello. Old is hello. Output location is 0. Let's go into our for loop. We'll say if old bracket I is not X. Let's look at old bracket I. That's the letter H. We should be good to go into our if statement. We're going to copy old bracket I to new bracket Outlook. Let's execute that. Let's look at new. New, is still exactly what it should be. Let's look at output location. That's a 0. We're going to increment output location. We're going to go back in here. We're going to look at character old bracket I. That's the letter E. Good. We're going to copy that to new bracket Outlook. Let's go ahead and execute that, and let's take a look at new, and something is wrong now. So let's take a look at Outlook, and Outlook is still 0. Well, we were about to execute this statement which says Outlook equals Outlook ++. Let's go ahead and execute that, and let's look at Outlook, and it's still 0. And this is another one of these, what the heck is wrong with the world? This doesn't seem to be changing the value of output location, right? It's another misconception about how these auto increments work. By putting the ++ at the end, this is saying let's use the value of Outlook and then let's increment it. But we're using the old value and assigning that to Outlook, which isn't changing it, and the auto increment gets dumped. It's a peculiar C thing that you would never figure out by just staring at your code unless you've seen this before, right? But the debugger forces you to realize this statement is not incrementing my variable. Why not? And maybe you go back and you change your code to Outlook equals Outlook +1, and bingo, it works. And so you put this on your mental post-it note and you say, let's figure out someday what's wrong with this, right? And then you can ask in class or something about that. So okay, that's a few examples of GDB. I've got one more munged version of clean. We can look at that tomorrow. But anyway, that's an intro to the subject. So I strongly recommend start playing around with GDB as you're trying to find issues with your code. it takes time to get used to it. It takes time to figure out the commands and stuff. But if you spend that time before it's critical, right, then when you actually need it in a pinch, you'll have the skills to use it. All right, that's all I got today. Have a good one. I will talk to you tomorrow.